Hey everybody, I got another series to talk to you about called the alternating series. And I'll go over the definition real quick and then show you a couple examples. If you have an alternating series that is decreasing and the limit of the series, of each term I guess I should say, approaches zero, then the alternating series will converge. And so there's one main key feature about an alternating series is you'll see this -1 to the nth power or the n-1 power or the n+1 power. You'll see it show up in there. And if you think about powers of -1, it will cause the sign, meaning plus and minus sign, to alternate. So if we find the first few terms of this, meaning substitute 1 in, substitute 2 in, substitute 3 in, the first term would be a 1 at the bottom, and it'd be -1 to the 0th, which is 1. And then if I plug in 2, which would be the next term, it's -1 to the 2 minus 1, which would be -1 to the first. If I plug in 3, 3 would be the denominator, and then I'd have -1 squared, which would be this. Those would be my first three terms, but you'd see it show up as 1, minus 1/2, plus 1/3. The next term would be -1/4 plus 1/5 on to infinity. That is an alternating series simply because it alternates signs, plus minus, or minus plus minus plus. That looks very similar to the harmonic series. It's actually called the alternating harmonic series. But the difference with the harmonic series and this one is the harmonic series, remember, diverges, and this one actually converges. Because it's alternating, the limit, right? These values are getting closer and closer to 0. Eventually, you'd have, -1/100, -1/1,000. It's getting closer and closer to 0. And then this idea of decreasing means that each term, meaning this is the second term, this is the third term, if you're ignoring the signs, the minus, plus, minus, plus, each term is getting smaller, meaning 1/3 is smaller than 1/2. And then, 1/4 is smaller than 1/3. So if it meets that criteria, then you can say that the series will converge. So a couple quick examples. If we look down here, just switch the color just to keep it fresh. So this example right here says find the series from n equals 1 to infinity. And then this is the thing that will make you think, okay, I have an alternating series. And when that little clue triggers your brain, you want to think about if it fulfills these criteria. And so I'm going to write the first couple terms just to make sure you can do that if you have to. If I plug in 1 as my first term, the bottom would be 1 plus 1, which would be 2. -1 to the first power would be -1. And then 1 cubed again would be 1. My next term is if I plug in 2, -1 squared would be a positive. And then 2 cubed would be 8. And then 2 cubed, 8 plus 2 would be 10. If I do one more term, n equals 3, again, I'm going to have a minus sign. That should be a 10 right there. It's kind of sloppy. 3 cubed is 27. And then 27 plus 3 is 30. So I really have this series, -1/2, +8/10, -27/30. And so if you look at the criteria, it is an alternating series. That's cool. Is the limit equal to 0? Well, this is 1/2. This is 4/5. So we have one problem there, is that this is increasing. And so we've gone against this whole decreasing up here criteria. So that's a bad sign. The other thing, if you go back to what you learned about limits, is if we're really looking at the limit of this, all we care about is the leading coefficient, and the limit is equal to 1. And so there's a couple reasons why this diverges. Because it's not decreasing, and the limit isn't equal to 0. The limit's equal to 1. All right, example 2. Again, we have an alternating series because of that. So if I kind of skip some steps, maybe find a few things, I know it's alternating, and then really I want to know the limit of this. And we know this is n to the 1/2 over n squared. And so if you use the powers that we've talked about, the leading coefficients, the magnitude, the limit actually is equal to 0. So that's a good sign. So really want to know, do the terms decrease? And so there's no quick way to find that. I mean, you can use your instincts to make an estimate. But if we find the first couple terms, meaning if I plug in 1, I'm going to get 1 over 1 squared plus 1. I got 2. If I plug in 2, I'm going to get the square root of 2 over 2 squared is 4 over 5. If I plug in 3, I'm going to get rad 3. And then 3 squared is 9 plus 1 is 10. Hopefully I didn't make a mistake there. And so I'm a little unsure about radicals, but if I do find the decimal approximations of these and confirm it, it is in fact decreasing from term to term. And so it is converging. That's a good sign. Okay, that's it for alternating series. Just a quick recap of what we've done so far, at least via videos. So here's your little cheat sheet so far. Geometric series, if your ratio is between -1 and 1, then the series will converge. Also, you can actually find the number that it converges to. That's the only type of series that we have a formula to actually find the sum. The P series has this form, and if P is greater than 1, meaning 1 over n squared, 1 over n cubed, then the series will converge. And if it's less than or equal to 1, it diverges. And then hopefully, if P equals 1, that is that harmonic series. Alternating series, we just went over. If it alternates and the limit's 0 and it decreases, then it converges. I should add on there, otherwise, it diverges. And then the other one that came up briefly is at the very beginning, if your limit doesn't equal 0, then that divergence test can be kind of handy for a quick kind of, don't waste my time on it, it's going to diverge. And so there's that. It is only one way, though. It's not an if and only if. And then the last test, which will be my next video, is the ratio test. And we'll use that when we're dealing with series that have factorials in it, where you can't really, we can't use anything else. It doesn't fill the following criteria. The challenge comes from the fact that you're going to have to look at a series and quickly determine which test to use. And you're going to go through your toolbox of tests and say, okay, it's not geometric, it's not a P-series, it's got a factorial, so I got to use this test, and kind of make that decision on your own. Until then, thanks for watching.